Computer education has existed since the 60s, certainly into the 70s, and in Australia's case, very much in place by the 80s. Predominantly focused in years 11 and 12 around pre-tertiary preparation for computing, but also other subjects throughout, certainly the secondary schooling. Now, in more recent years, we've seen a trend towards going to a much broader curriculum, covering the primary years into the lower secondary years, and then culminating in the final years of schooling, our senior years. Now, Australia's been one of the leaders in this space, but not the only one. Britain is a year ahead of us, and there's a few other countries like Estonia and a couple of others that were ahead of that even still. But in the main, there is a global movement towards a much broader inclusion of computer education in schools. Naturally so, because of computing becoming so much more of an important aspect of society. So in the main, there's still a distinction between the Year 11 and 12 computer science, preparing students to go into studies of computing in tertiary, and a more broader curriculum in the other years, often called ICT, or Information and Communication Technologies. Now, there are many countries in the world that are still teaching ICT just in Year 11 and 12, and they haven't gone towards teaching computer science, essentially programming and information systems. So they're still teaching about applications, how to use different computer tools, how to use a computer, how to use various items of software. So that would probably represent a good 2/3 of the world. In Australia, we do that in our F to 10 curriculum, from foundation through to year 10. But we also have now introduced computer science elements into that F to 10 curriculum. So that's quite a distinction. Only a few countries have done that so far, and it's often framed around the concept of computational thinking. So there's a general shift now towards not just broadening the curriculum so that there is computing taught in all year levels, and again, that hasn't been achieved in most countries, but also a shift towards teaching basic computer use towards being able to create with computers, being able to program, utilize databases, a whole range of other more complex skills that were traditionally only introduced in Year 11 and 12, or in the final years of schooling. So there's been quite a shift occurring in that space, and you can read about that in some more detail in the course notes. So there's three main schools of approach to this new movement: what's occurring in the United States, what's occurring in Europe, and what's occurring in the United Kingdom. And we tend to follow the United Kingdom model, but that's slowly merging with the US model. We tend to be great followers in Australia rather than necessarily leaders, although we certainly were in this space before the US. The US has got a lot of clout in terms of curriculum development and development of resources and activities and so forth, so they do tend to influence what occurs. But there are three major schools of thought around this trends in computer education. So in the USA, it's very much around the idea of computational thinking for all students. So all students should learn about programming, but very much based within a framework of what we used to call ICTs, or digital literacy. So it's not necessarily emphasizing programming. Programming is certainly there, but it's not the emphasis. It's around about a whole set of computing skills that every student should learn about. Now, the UK and Australia took a slightly different approach, much more around having subjects that teach computational thinking, or digital literacy, or digital technologies, and focusing on those subjects, preparing students to be able to do computational thinking, learn about computing, learn about programming, and so forth, rather than it being a responsibility across the entire curriculum. In Australia, we're doing a bit of both. We have our subject, digital technologies, which focuses on preparing students around computational thinking. And we have another subject called, or we have another curriculum called digital literacy, which runs in parallel. And it's called a general capability. In Europe, it's a little bit different still, where they focus on a concept called informatics, and they still have many of the same outcomes as what's occurring in the UK and Australia, but there is somewhat more of a formal emphasis on developing the thinking skills associated, rather than the practical applied skills that we tend to see a focus on in the UK and Australia. So it's a bit of a mix and a mess at the moment. Eventually it'll probably consolidate into one particular approach, but at the moment there are a range of approaches. And one of the key things you need to be aware of in that is that if you find resources that have been developed in Europe or in the UK or in America, they may have a different particular approach to what is expected in Australia. And so you may have to modify them to some extent. The other aspect is that there are some international measures of students' computing capabilities that are conducted. There are the ICILS studies that are conducted by the United Nations. And there's also particular studies called the TEL studies conducted in the United States that are done annually to see how countries, and in the United States, how states are comparing with one another. Now, in the main, Australia has opted not to be involved in those studies, and we conduct our own studies as part of our national assessment program. And we call it the Australian National Digital Literacy Assessments, or the NAP-ICTLs. So they're done every 3 years, and they're done on a sampling. You may have heard of the NAPLAN tests, which are the National Assessment of Literacy and Numeracy. This is part of that same program, but it is done focused on computing skills, and it's done on what's called a sampling process. While NAPLAN, every student has to participate in years, I think it's 9, 6 and 3 or something like that. In the NAP-ICT, it's only done with year 6 and 10 students, and it's done on a sampling basis. So only certain schools are selected, and we then average the results, assuming that they are representative of the entire population.